Hi, everyone. Welcome to the OWASP Toronto December meeting. We're just going to give people 5 minutes or so to trickle in, and then we'll get started. All right, so I think we're going to get started then. So welcome to this month's OWASP session, everyone. As usual, if you're looking for a job or looking to hire, feel free to post your LinkedIn profile or job posting in the comments. And yeah, below the video, you'll also see our feedback form for this month's meeting. We'd really appreciate it if you guys don't mind filling that out. If you would like CPE credits, it is a requirement to leave your name and email address in there for us. But yeah, well, I think that's everything. We'll get started. Welcome, John Simpson from Trend Micro. Really excited for your talk. I'll let you take it from here.
Thanks, Jack. All right. Hey, everyone. Nice to be here. Thanks to OWASP Toronto for having me. So the title of my talk today is EBS, TCF, SQLi, Shaking My Head. A cautionary tale about undocumented protocols and whac-a-mole patching. So let's get right into it because we have a lot of fun stuff to cover here. All right, so just a little bit about myself here. I'm the current team lead and a staff researcher on Trend Micro's end-day vulnerability research team in Toronto, Canada. We used to be known as TELUS Security Labs. For those of you who've been around a little while, we were acquired from TELUS a couple years ago. Previously, I was a Big Four consultant. I did some SOC engineering, penetration testing, vulnerability assessments, secure code auditing, that sort of stuff. And I graduated from Sheridan College's Information Systems Security degree program, which both Adam and Jack are graduates from as well, and I know there's a lot of them around in the industry in Toronto. And I'm one of those kind of crazy obsessed pet parents. That's my corgi Jasper there, making a face. All right, so let's get into it. So a little bit of background on what I'm about to talk about today, kind of how I got into this whole thing in the first place. So what our team does is we perform analysis of known vulnerabilities. So our end goal is to create network-based detection guidance for exploitation attempts of a specific vulnerability. So we analyze hundreds of vulnerabilities per year as a team. Many of these vulnerabilities do involve well-documented protocols, file formats, APIs, etc., and many of them don't. So today I'm going to be talking about my analysis of several vulnerabilities involving an undocumented protocol in Oracle e-business and how I found two very easy 0 days along the way. Okay, so Oracle e-business suite, for those of you who don't know, it's a collection of ERP, CRM, and SCM applications all thrown into a single sprawling platform. Big competitors tend to be SAP, for example. So this is like hefty enterprise software we're talking about here. So in November 2019, ERP security vendor Onapsis released a campaign around vulnerabilities discovered in Oracle e-business, and they called this collection of vulnerabilities Payday. Now the name was not necessarily based on anything about the actual vulnerabilities themselves. It was about what an attacker could do post-exploitation in order to, do bad things to the organization. So some of these vulnerabilities were reported by Onapsis and patched in April 2018. Others further were patched in April 2019, and they found even more that were actually patched in January of this year. In general, details were basically non-existent beyond the fact that Onapsis said that the vulnerabilities involved something called the thin client framework. As a kind of a side note here, Martin Doyenhard and Gaston Traverg of Onapsis very recently gave a talk at Hack in the Box Lockdown 2, and they actually gave a little bit of detail on a couple of their TCF vulnerabilities, but they really didn't go into any details on the protocol, which is basically what we're going to do here today. All right, so what is the thin client framework? It was developed to facilitate the use of newer Java-based components in EBS. I use the term newer very loosely because this is Java we're talking about and Oracle. So previously, you would use a technology like Oracle Forms, which was a little more limited in terms of what you could do with it. TCF communication, originally when they first launched it, it took place directly via socket. As of Oracle EBS release 12, TCF messages are passed in the body of HTTP requests and responses. So what frequently happens with our research is we'll often encounter a product that either I personally have never worked with before, or no one on our team has ever worked with before. We're a small team of, usually 8 or 9 researchers, and, we can only cover a certain number of products in a year. And, when we encounter something exceptionally difficult, sometimes we can't spend the time to learn it in order to really dive deep. So in this particular case, I'd never used eBusiness in any context in any of my previous jobs, working with any clients, anything like that. I'd never used it before, never touched it. So when we're encountering something like this, step one for us is always to gain as much information about the product and the affected component as possible before we touch any software at all. So, I basically Google like crazy and try and poke around and see what I can find. So initially I found little to no information about what Thin Client Framework was at all, or any of the affected EBS applications. So in that case, what I tend to do with a product that I've never used before is I like to get an overview by reading the documentation, playing with the application, etc. Well, with a giant sprawling enterprise, ERP application like this, I really have no chance of that being terribly effective. I'm not going to possibly walk through even a fraction of a percentage of the functionality of the application just by poking around randomly. So when I deal with that kind of situation, then we have to sort of start to focus exclusively on patched and vulnerable components. So, we'll inspect the patch to see if any files in particular stand out, and this usually helps reduce the files and code that I have to hunt through. Big emphasis on usually. So in this particular case, I basically started fumbling through tons and tons of Java. It's Oracle, obviously almost everything Oracle is almost purely Java. So I did a bit more hunting on Google. I did find a blog post from another ERP security vendor, Integrity, and they mentioned a URL for the Thin Client Framework server. Great. So now I had at least like an endpoint that I could maybe poke at, or that I could look for. So the patches contained a whole bunch of directories, all these like zip files named with 2 to 3 character identifiers, and then we had these, so the zip files there, and then we had these directories with similar 3 character identifiers. So honestly, oftentimes what I do when I don't really know where to look in a program for a particular piece of functionality, I use grep. Grep is probably my #1 used tool when it comes to vulnerability research. So I literally do grep-r, so a recursive grep for that apps TCF server endpoint. So I didn't find anything at first. I thought, okay, well, there's a lot of zip files in there. Maybe it's in one of those zip files. So I unzipped all the zip files, and I did another grep. Still nothing. Haven't found a thing. So my next desperate measure, which is oftentimes a bit time-consuming, especially with software of this complexity and this magnitude, I usually do a grep-r on the entire product directory. And typically that usually calls for a coffee break of some sort. And in this particular case, yeah, doing a grep, a recursive grep on the entire Oracle EBS directory tree can run 30, 40 minutes quite easily. So grep did find me something though. As I said, one of the most useful research tools that we have when we're, really just starting to dive into a new application. So, I found, hey, look, web-XML, servlet mappings there, the URL pattern, perfect. So I have a web-XML file, location of a web-XML with servlet mappings, which means I can find a relevant class file. So in this case, it's, this socket server class. Great, awesome. And I also kind of noticed that, hey, wait, part of that package name, that FND there, that looks pretty darn familiar. So, looking in the patch folder, we had a couple of FND folders. We also had a zip file that ended in FND. Okay, great. Feels like we're getting somewhere. So next step is to break out the Java decompiler. So my tool of choice for that, because there are a number, and the most popular tends to be JD GUI. I tend to use the CFR Java decompiler. You can just Google CFR Java decompiler, you'll find it. If I want line numbers to match up for debugging purposes, I will sometimes switch to JD. I also will sometimes take my chances with IntelliJ's built-in Fernflower decompiler, simply because it'll decompile stuff on the fly as it needs to, which is pretty handy when you're trying to debug something you don't have the source for. So first step for me was I grabbed the entire FND directory tree from EBS. So as a side note, when I did this initially, I didn't really think to check if any patches were pre-installed on the VM. There wasn't a single one. So Oracle provides these, sort of pre-configured virtual machines where all you have to do is, change some passwords and you're good to go. And I sort of assumed that maybe they would have some patches, but Oracle basically does major releases, and then it's up to you to install any patches in between those major releases. So my unpatched tree actually also included the vulnerability that was fixed in 2018, and we'll talk more on that in a little bit. So the next thing I do is I extract the relevant zip file from the patch, so that number_fnd zip file. I decompile all the class files into two separate directories, an unpatched and a patched directory, and then I run a recursive diff between the directories containing the unpatched and patched code. And we'll start, a lot of times you'll see, just due to decompilation issues, you'll see a whole lot of junk, but it's usually pretty easy to just scroll through quickly and filter out the junk from the good stuff. So this was one of the things that kind of really started to stand out, and I was like, oh, hey, look, this log message says TCF session start attempted without authentication information. Clearly I'm onto something here. So this change happens to be in that socket server class that's mapped to that app's TCF server endpoint that I mentioned before. So this is actually part of the patch for the authentication bypass that was patched in April 2018. It's only tangentially related to the vulnerability I was supposed to be investigating at the time, but it was still extremely valuable that I saw that. So at this point, I said, okay, I see this patch. I don't really know what's going on with any of this yet. So I felt it was necessary to start understanding what thin client framework actually is. So what I tend to do is I load up Burp Suite, run my browser through the Burp proxy, and see if I get any hits on the URL I'm interested in as I poke around the web interface. So for me, it's basically all about speed and just like, how many different things can I click through, and can I, at some point, see that URL pop up that I want. And this is basically how it goes with something like Oracle eBusiness. It's such a sprawling, big, confusing piece of software that it was so confusing for the first little while. So this is where I kind of say, okay, you know what? I'm going to go back and just start reading code. Now, in hindsight, it wasn't necessarily the best way to start, but on the plus side, when I did finally see real traffic, I had a general understanding of what was happening. So what I did is I started by looking at the DoPost method of the socket server servlet. So any HTTP post requests obviously are going to get handled by that. So basically, I've highlighted this first line here, which is get header TCF session, and another line, get header TCF start. So requests seem to involve in some way TCF session and or TCF start headers in the HTTP request. Okay, cool. So yeah, it doesn't seem so bad thus far. So we get that TCF start header. We're checking to see if we have an HTTP session. If there's no current HTTP session, so you'll see like those JSessionID cookies, which are fairly standard for stuff running on like Tomcat, JBoss, any of those like J2EE applications. So if that TCF start header is present, we create a new HTTP session. If TCF session, that header was present, it's going to check and see if that actually corresponds to an existing session. If there's no TCF session or TCF start header, it's just going to create a new session for you anyways, because it just assumes that's what you wanted to do. Which, okay, cool. But that's where I start to kind of get a little worried about what's going on. So when a new session gets created, whether because you sent TCF start or because you didn't send anything in terms of headers, special headers it recognizes, it sets that BL Boolean there to true. And this results in a new connection object being created, whatever that is. The session ID for the object gets set. which is right here, set session ID. And then we call this read handshake method with our input and output streams. So if this is in a new session, an existing connection object gets retrieved, and instead we call this dispatch round trip method. So what exactly is that? Sorry, just going back here, that read handshake method. So what is this handshake that they're talking about? Well, so the connection class that contains that method is in the Oracle Apps FND TCF net package. So we have, the first thing they do is basically it reads a 4-byte big endian integer, 1 byte at a time. So you know this because what they do is they're reading integer, 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 integer here. They're checking a value, but then they're doing bitwise shifts. So doing a 24 bitwise shift, a 16 bitwise shift, an 8 bitwise shift, and then I don't know why they have a bitwise shift of 0. That could just be a weird decompilation thing. But essentially they've reassembled this big endian integer. So that gets stored into this N5, and apparently that value can't be larger than the length of this constant string up here, which is handshake response. So that string is made up of constants from the socket server class that we were just looking at before. And essentially, this is what it looks like all put together. So these are the different components. The title is TCF/SP, V, and then version major is 1, version minor is 1. And so we wind up with this TCF/SPV 1.1. And they add a period on the end of it, but apparently that's not mandatory at all. All right, so still continuing on with the handshake here. So clearly that 4-byte integer is a length value of some sort, because what happens is we create a byte array of that size using that N5, and then we call this read fully, and we're reading that many bytes into the array. So that read fully will basically fill up whatever size byte array we throw at it, as long as there's data to fill it. So the next thing it does is it uses string tokenizer, and it splits the string using either V or period as limiters. So it'll split anytime it encounters a V or a period. So what it's doing that for is so that it can check the title and version components of that handshake string that it receives, and if the title is correct, it'll send a response, but this particular read handshake method is only going to return true if the version is a match as well. And as far as I've seen, I've only ever seen 1.1 as the version string here. All right, so let's go back to DoPost in our socket server class here. So if that read handshake returns true, the connection object winds up getting stored with the session. So that's this guy here. And if another request gets sent with the valid TCF session header, as I mentioned before, that connection object is still there, and its dispatch round trip method winds up getting called. Okay, so dispatch round trip. So the first thing that happens is they call this read big UTF. So there's a read and write big UTF, and essentially what it is, it's almost identical to the start of read handshake. It reads or writes a 4-byte integer and followed by that many UTF-8 characters. So the next thing it does is it looks for a colon in the string and checks if the string before it, which is this gray part I've highlighted here, is A or S. And depending on whether it's A or S, it calls server dispatcher.receive or server dispatcher.receive_sync for S. So right away, that kind of pops out as being, okay, they're talking about asynchronous and synchronous calls. So calls where you wait for the response versus calls where you don't care if you get a response back right away. Okay, now things start to get even a little more complicated. So server dispatcher is an extension of the dispatcher class. The parse async and parse sync methods are called from the relevant server dispatcher receive methods. So both async and sync calls are handled by a loop that terminates when all items are read. And so we have this again, input buffer more items, and then we call this.parseItem. Parse async is very similar, but calls this.readItem instead of read sync, and it has no output buffer. So, okay, we're going to parse items, read items. What on earth is an item in the context of Thin Client Framework? Okay, so this ParseItem method starts with a call to ParseItem header. PartsItem header looks for a closing square bracket, and if found, it returns the string up to that character. So it doesn't actually parse the header, it basically just locates it using that closing brace. Input buffer.read2 is basically going to return, which is what I've highlighted in blue there. It's going to return the string containing characters starting at the current index in the buffer and ending after the number of characters specified in the method argument. So for example, it said, okay, the index of that closing bracket is n. We want to read everything from our current position in the buffer to just after that closing bracket. So the item header, which is what it just called that parse method on, it's basically two integers as strings separated by a semicolon character. So we have string index of semicolon, and then we have two calls to parse int on substrings using that index to tell us where the integers start and stop. So then we do this like read to one call, but you'll notice that like this string 2 never gets used anywhere. Like this method ends and that string 2 just doesn't get used. So basically what happens is it's reading, enclosing characters of some sort, but it doesn't care what they are, which is always fun. So the second integer n2 that it reads seems to be the item length because it calls read to n2. So it's wanting to read that many characters. As I said, read to 1, those get ignored. The first integer appears to be something called a proxy ID, because in this gray thing here, we're using that first integer n, and we're using it as an argument to new proxy ID. Again, at this point, we have no idea what that is. So we are creating a new object, a new item object, using the proxy ID and that item string that we just pulled out. So just to kind of recap, because I know this can kind of be a little overwhelming at first. So a TCF request will have a format something like this. So it starts with A or S, then a colon, followed by any character, followed by a proxy ID, which is an integer, semicolon, an item length with an integer, a closing square bracket, and then apparently any character, the item characters, and then again, any character. And that's basically what we're looking at as far as what the server cares about. Okay, so now we're actually going to look at TCF items. So the item class has a whole bunch of these constants defined. So you see this like string, int, date, double, and they all have a 2-digit number beside them. We also have these like item delimiters, sub-item delimiters. So those are nice and descriptive and kind of give us a little bit of help here. Now, that's great. Helpful, except when we look at the item constructor, it's just this. It's literally new proxy ID, new string buffer. Oh, okay, yeah, that's super, super helpful. That's totally what I was expecting, which is to say not at all. So, but further answers actually lie in the read item and read sync methods of the dispatcher, because various methods of the item object are actually called from there to parse the items themselves. So let's talk about sub-items. So there's that loop. What if item has more sub-items? This guy right here. So both read sync and read item begin by checking if there are more sub-items, then call item get next string, which calls get next value, which calls get next name value type, which is a heck of a chain. So what happens is that the type is located right before a colon character. Again, we have this index of colon. We're taking a substring up to that colon. And then this seems to be followed by either an N and or a V, because notice these are if and if, not if, else if, or if and else. And each of these are followed by a token. So if I encounter N, then I call this get token. If I encounter V, then I call get token. And again, who knows what that is? But one thing to kind of note here is that string 4, that actually gets set as name value type dot type. So that would seem to kind of correspond to what we were looking at on the previous slide, where we saw those 2-digit types. All right, so what the heck is get token? Get token looks for yet another colon character. Before the colon is an integer. As you'll notice, we do integer parse int on string, which is that string that we just read. And then that many characters go into string 2. So again, this seems to be basically like another length thing. So this is where we're doing string buffer, substring, and we're using n position plus n2 as the as that position for our substring, or for the end of our substring. So at this point, there seems to be kind of three possible options for a name value type sub item. So we can have the 2-digit type, a colon and an n, a name length, a colon, a name, any character, v, value length, blah, 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 blah. So we can either have a name, a value, type, name, value. We can have type and value, or we can just have a type, and that basically just means it has a null value. getNextString then calls getNextValue, and that only returns the value. It doesn't seem to care about the type. So they're basically only grabbing, if we look here. So see how it says return name value type, but the way that we actually got to this method, that those methods that call it only care about the actual value, not about the type whatsoever. So handling the very first string. So after we've read that first sub item, we've gotten that first value. Both async and sync requests check that value against a whole host of different values. There's basically just this long, if-else statement that goes through and checks against all of these strings. So like plus, minus, period, IC, ICX, blah, 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 blah. Sync, similar, CS, IV, IVS, IVT, etc. At this point, again, we still have no idea what any of these are actually for. So a matching value determines how the rest of the item is structured. So after each one of these matches, you would essentially see, okay, it's going to read an integer and then two strings, or two strings and then, some bytes. So yeah, that basically tells us kind of here's how it expects the item to look. The kind of side bonus is many of the items have descriptive log lines. They at least give you a hint of what a particular item is used for. So in this particular case, we see this log line, initializing context. I have no idea what any of these things are, but, okay, initializing context. Okay, that sounds like something that needs to be done early on. So the issue here is because there's so many of those different strings, it's kind of tough to piece together the order that we have to send these different sort of commands in. So this is the point where I got to. I said, okay, I sort of see what's going on. I have a bit of a grip, but I need to actually go and generate some actual traffic now. So when I get stumped trying to generate normal traffic, I'll tend to go over the security advisories again to see if I overlooked anything. I'll hop on Twitter. I will Google like crazy. I'll go through product documentation again to see if anything steps out. Oracle's security advisories actually specify a product and component. The product corresponds to the specific e-business application. In this case, it was the Oracle General Ledger. So when I logged into the web interface as sysadmin, I couldn't see anything related to General Ledger whatsoever. I looked through every menu, and I was like, I don't see anything that would indicate that. But it seemed reasonable to me that for a really large ERP application that sysadmin wouldn't automatically have access to everything in the system. They would still have to be granted permission to access stuff, because obviously you're running, let's say, like a Fortune 100 company. This is running a huge portion of your company. Your sysadmin shouldn't be able to just automatically go in and access anything and everything without making some changes, or adding and updating some roles. So through the user management interface as sysadmin, I was able to grant myself several roles that started with General Ledger. I basically said, oh, these all say General Ledger. Okay, let's add all of them to my user. So the EBS virtual machines, they do come preloaded with this Vision demo, which is essentially like a fully fleshed out e-business suite install, has tons of users, roles, sample data. So, all this stuff is kind of pre-configured in a way for me. So I didn't have to do like any really intense customization and configuration, which was actually kind of a big help. After another hour of fiddling or so, hey, look, we got traffic. This is just dumped from Wireshark. We have, post to TCF server. We can see our TCF handshake there. We can see the response. You'll notice that my client doesn't actually send the period at the end of the handshake, but when it responds, it does. So, okay, it clearly doesn't care about that. And then we see another message here, and we're going to kind of dive into that. So, authentication and session setup. So once I was able to generate that traffic, understanding the authentication and session setup was a little bit easier. So the first message sent by the client that I just showed you as a handshake. So based on what we've already looked at in the code, we know that this is a synchronous request, which is that S there. We know that it's using a proxy ID of 0. We still don't fully understand what that means yet. We just know, okay, that's proxy ID 0. And we know that the length is 87. And the first sub item has a type, so T00, which is that G string constant, and a value of IVT. So it's basically, okay, first sub item is a string that's IVT. Now, you'll notice that there's some characters in the request that the client sends, but based on the code are not required to be there. So if you notice when we were fleshing out the structure, there were a lot of places where we said, oh, this could be any character. And it's true, the server actually doesn't care that you have these nice enclosing braces here. It just wants that closing one. And it doesn't care if you use curly braces here at all at the start and the beginning of the items. You can literally put anything there and it could not care less. So what is this IVT thing that sends? Well, there's a log line in one of those methods that basically tells us what it is. It says, okay, invalid ticket received by dispatcher. Okay, T maybe stands for ticket. So we got to inspect the code a little bit further. So if that string starts with IV, it expects another string right after. So it does item get next string. In that case, in our request, it's the string EBSDB, which sounds pretty normal. But then it uses that string to create a web apps context object. And then it stores that with the current object, which is the dispatcher object. So then it basically says, okay, it started with IV, but if the string is actually IVT, which is what we have, it gets another string, and it's going to call this one-time use retrieve method with that new string as one of the parameters. And it's this weird long string, and so the assumption is kind of that it's something to do with an existing session. So that integer is then used as a call to validate session, which is in the gray there. So it retrieves string 5 here with this call to one-time use retrieve, and then that gets turned into an integer here. That integer is then passed into validate session. So clearly this is something to do with, okay, we have an existing session that we've logged in through the EBS web interface, and we're sending this ticket as a way to authenticate to the thin client framework in some way. Okay, so let's talk about how they do session verification here. So web apps context validate session calls this do validate session method. In general, it calls a stored procedure in the database. So obviously something's in the database to verify that this session exists. And from this, we can make a few assumptions. So the client was given or derived the ticket string after authenticating via the web interface. The ticket string is processed in a way that returns an integer, and that integer is present somewhere in the database that stores session tickets. Okay, cool. So what's the result? Well, the result in terms of what actually happened of consequence. Well, it created a web apps context object. It stored it as that mctx object in our dispatcher. Then validate session and check session calls didn't really actually seem to do anything except it'll return a string saying success or some sort of failure string. So great, it returns a string to the client, but does that actually mean anything at this point? And right now, at this point, we really don't know. So let's look at some subsequent requests to try and get a little bit more understanding. So the second request from the client, after it receives a success from that, so this is an asynchronous request, so you can see by the A there, and it's got 2 items. So you can see the first item in blue, the second item in red there. So the first one has a proxy ID of 0 with a length of 83, and the first sub-item has a type of 0, which is again the string constant, and a value of plus. So it's literally just plus, that's the whole string. The second sub-item clearly has some sort of full package and class name here, ending in data manager server. And the second item, curiously enough, has a proxy ID of 1, which we hadn't really seen up until this point, has a length of 10, and then it has just one string sub-item, which is that string IL. So for the first item in read item, so we can see that string compared to plus. If that's a match, then we call create proxy. So what is a proxy in this case? Well, the create proxy first reads up to 3 additional strings. It'll basically use, essentially it's going to go, if there's more sub items, get next string, get next string, get next string. It's going to do that 3 times if there are strings to read. Then what it's going to do is the very first string is going to get passed into this proxy factory new proxy method. So it's going to pass that full class name in that I showed you earlier, that data manager server. So if that returns a proxy object, then the next string is the proxy ID. So you'll notice here new proxy ID is string 2. So it basically, what happens here is that proxy ID is used to provide forward and reverse mappings between the proxy object and the ID. So it's basically putting, string 5 proxy, proxy string 5 in these 2 dictionaries here, so that you can do sort of forward and reverse lookups to say, okay, this proxy object belongs to this ID, or you can say that this ID refers to this proxy object. So the third string is provided as an argument to the init method of the new proxy object, which is this unhighlighted thing here, along with the current server dispatcher object. So in that case, this is completely null. So what are proxy classes? Well, proxy factory is just an interface, but it's implemented in default proxy factory. The new proxy method is really simple. It basically creates a class object from the provided string. So what that does is that gives you, calling class for name. You pass in the string of a full class name, and all of a sudden you'll get an object that refers to that class. And from there, you can create new instances of that object. So you do class, you call new instance on that new class object, and you're going to get a new object of that class. And you'll notice that, due to decompilation, you'll see this is just like a kind of a generic object, but the method has to return a proxy or something that's derived from that proxy class. So yeah, that's the main caveat. The object has to be castable as a proxy object, but that data manager server class from the request implements the synchronous proxy interface, which happens to extend the proxy class. So we can assume that an instance of this class is now mapped to a proxy ID of 1. Because if we go back and we look, that third string there was just a 1. So that's actually our proxy ID that we've chosen for this new proxy object. All right, so now interacting with the proxy classes. So you'll recall that the second item in the second request had a proxy ID of 1. So parse async and parse sync methods in dispatcher will actually check if the proxy ID is 0 or not. So if it's 0, it calls read item in parse async. If it's not 0, it calls dispatch item. Cool. So that sounds like we're kind of getting into interacting with some somewhat arbitrary classes at this point. So what happens when you call dispatch item as opposed to read item is it looks up the proxy object from that dictionary I mentioned before using the ID number, and then it calls the read item method of that particular proxy object. Okay, so we've gone over a whole heck of a lot of stuff here. So let's do a really quick recap. So we've got a basic understanding of the TCF handshake, TCF items, including the item headers. We have an idea of what session verification looks like under normal circumstances. We have an understanding of what proxy IDs are for and how proxy classes are instantiated and interacted with. But at the moment, we still don't know what the results of the session verification actually did or anything about the vulnerabilities, because we are here to talk about vulnerabilities, right? And we haven't even gotten there yet. So let's get into some vulnerabilities, and let's start with that authentication bypass that was patched in April 2018. Okay, so let's have a look at the patch in Socket Server from April 2018. So on the left here, you have the original, and you have this, get header TCF start, and then, okay, if the string is not null, we, try to get a session, and, we'll create a session. So get session true basically says if a session doesn't exist, we're going to create a new one. And, if that happens, then we're going to set that Boolean to true, which creates that, connection object for us. So what they added in the patch is they added a reference to web apps context, which you may remember from our dispatcher class that we were looking at before. And what happens is that we now have this validate context with our request and response, and it tries to retrieve a web apps context object. And if that's null, or it exists and it's bound to a guest user, then all of a sudden we now have this TCF session start attempted with authentication information error thrown at us. So what that implies is that you could start a new TCF session without authenticating to eBusiness first, which right away that should be setting off alarm bells. So there were more issues in the dispatcher as well. So in the dispatcher, in both parse async and parse sync, I've just shown parse async here, they've added on the right here, you can see this check access and item.mid, which is actually, that's the proxy ID. So check access uses a security manager class to ensure the user is permitted to access a given class, proxy, or otherwise. So in other words, any user, including guest users, so someone who has a session but isn't actually authenticated, could have any TCF message processed, which seems really, really, really bad, and it is. So simple step-by-step to bypassing authentication in an unpatched Oracle EBS. First, really quick, I just want to note something about the data manager server proxy class that I mentioned earlier. So most of the synchronous proxy classes I encountered through my research make use of that web apps context object that's stored with the dispatcher, not the one that we just looked at in the patch, because that was added and didn't previously exist. But with that in mind, we can actually create a valid TCF session as follows. So we initiate a TCF handshake with a TCF start header. We can set it to something random. It doesn't even matter what it is. We don't even need an existing HTTP session, so you don't need to send any cookies on that first request. So you'll get the handshake back. Then the next request you send, you can initialize that web apps context object with really minimal fuss by sending the following asynchronous request. So we have this asynchronous request here, and the only two strings I send the first string is ICX, and the second string is EBSDB. And so this is what happens in the code. If string equals ICX, basically gets the next string, which is EBSDB, and then it says create web app context, and then it binds it to my dispatcher. That's it. And then now you have this web apps context, and any proxy class that needs it or relies on it is going to be perfectly happy at this point. Whereas previously, to get that, the other method that we looked at in the normal traffic, you sent a ticket, and if that ticket verified, then okay, it would create the web apps context. So basically at this point, now we can create a proxy to the proxy class of your choice and begin sending requests to the proxy. And at no point did we ever send any log information whatsoever, just basically the handshake and one request, and now we're in and we can send whatever we want. So let's talk about the component-specific vulnerabilities. So once I had figured out the authentication bypass, I kind of realized, okay, the vulnerability I'm looking for right now is not that, but clearly it's related in some way. So I had to investigate the actual vulnerabilities that allowed me to do what Onapsis described, and it was basically compromise the whole system. So since I now understood how to instantiate proxy classes and interact with them, it was kind of just a matter of investigating any patched proxy classes. So the difficulty, once again, is locating the affected component in a really big patch. So remember that this that I showed you earlier. So we have, again, Oracle General Ledger and Consolidation Hierarchy Viewer as the component. So I use that information for each patch to help me locate the specific EBS application in the patch and quickly narrow down the classes I wanted to look at. So to do that, again, I used grep, as I often do. Each patch contains this driver file, which is basically just a text file, and it contains metadata about the patch, so like internal Oracle bug IDs that have been resolved by the patch, as well as instructions used by Oracle's patching application to actually tell it how to apply the patch. So the metadata happens to contain what is essentially like a translation from the abbreviated name to the actual application name. So as I said, grep, I literally did a case-insensitive recursive grep for General Ledger, and boom, there it is. And we saw General Ledger here in this driver file and GL right beside it. So now I knew, okay, I need to look for the GL directory in the patch as well as in EBS itself. and check out the zip file ending in GL. And you may have also noticed GL in the package name for the proxy class in the normal traffic that we first looked at. So as it so happens, and we love working on patches like this, that data manager server class was the only class file patched in the general ledger application in April 2019, which was what I was looking at the vulnerabilities for April 2019, and that's what I was meant to be investigating. So we're gonna kind of go through a few of the relevant CVEs here. So this was the first one in general ledger. So the patch essentially just involves removing handling for an entire command in the read-sync method of data manager server, which is the synchronous proxy class for general ledger. So read-sync is what actually gets called on the proxy class when it's synchronous. I'd mentioned read item when it's asynchronous, whereas read-sync is when it's a synchronous call to a proxy. So they removed this command. So you can see right here in red I've highlighted, this is where it starts comparing strings. So it's doing very similar to the way that commands sent to proxy ID 0 work, except they're now just being handled by this different class. So, checks the string, compares it, and it goes through this whole if, else if, else if, else if. So what was removed was this whole GV loop. So it's compared to GV loop. This whole thing, this whole chunk of code was just completely ripped out. Which is always a dead giveaway that I should obviously focus very closely on that. So it also reads 5 additional strings. So as soon as it says that's a match, it says, okay, I'm going to read 5 new strings right off the bat, some of which may be empty. The 4th additional string is actually expected to be a number, but it won't throw any critical errors if it's not a number. So what on earth are all these strings for? Well, this is where the fun starts. So the first additional string is passed into a method, create view object from query statement. So this is a publicly documented method. If you Google this method on, just throw it into Google, you'll find Oracle's documentation for this API. So the second parameter, which is, one of those strings we're passing in, is the SQL query that defines the view object. What could we possibly do with that, considering we seem to have 100% control over that? So the remaining strings are put into an array and they're passed into the set where clause parameters params method on the new view object. That's also publicly documented. So the method description is specifies the bind variable values to use with the view object's where clause. Then it calls execute query. So as a result, an exploit can have an arbitrary SQL query, but it must have a where clause with 4 parameters. And the reason why I found this out is because I kept throwing stuff at it and I kept getting these bind errors. And essentially, when it calls that set where clause params and it doesn't have the appropriate number of parameters in the original query string to bind that array of parameters to, it'll fail every single time. But at least it threw descriptive error messages for me. So we know exactly where we can throw this arbitrary SQL query now, but what do we actually want to send to cause the biggest impact? And again, essentially take over the whole system. So here's where SQL starts getting kind of tricky. So this is what I eventually came up with, and I'm going to kind of break down this whole payload for you. So the first part of the query, so here in blue, this is essentially just to make the view object parameter binding happy and have a valid query that's not going to throw errors when executed. So yeah, basically just through a random query, I said, okay, select this from this table that I know exists where username equals this parameter that I actually provided. And then I basically just did these garbage parameters where 2 is literally going to equal 2, 3 is going to equal a numeric 3, and 4 is going to equal 4. Great, perfect. But then we chain that to a couple of these execute immediate. So this next one in red, this is to ensure we're working with the correct schema in the Oracle database, which is the apps schema. And that's where basically all of Oracle eBusiness tends to be contained in. And execute immediate basically lets us run dynamic SQL statements or even anonymous PL SQL blocks. And so what I mean by that is that a lot of times in like a select statement, you're you can't do like data definition. You can't create or insert new stuff quite frequently. You're kind of restricted to, other select statements only. But with execute immediate, we can do literally anything we want. So basically the last step is I craft an anonymous PL SQL block that invokes a very well documented FND user package change password stored procedure. And what this stored procedure allows you to do, because again, you're executing this as the app's user in the database, is you can change the password of any user, including sysadmin, to absolutely anything your heart desires with, just that one payload. So at that point, with any account under attacker control, the sky is absolutely the limit for post-exploitation. And this is where the payday name came from, and where these post-exploitation scenarios that ONAPSIS detailed came from, is the fact that you can really just create an absolute mess at this point. Okay, so let's look at really quickly at another. I'm not going to go into huge details on this one because this one got actually quite complicated. So this was another vulnerability from the same April patch day. This affected the work in process application as opposed to general ledger. So this one affected the proxy class Oracle Apps WIP TCF server postmaster. So messages to server postmaster were really different. This one was actually kind of fun to look at, but challenging at the same time. So it only accepts synchronous messages. And the synchronous messages contain bytes items, so that type 7, whereas type 0 is a string. So the values of the bytes items, and I'm going to take this a bit slow because it's a bit confusing. So the bytes items are created by treating a byte array, a Java byte array, as an ISO 88591 encoded string. So what that means is that values up to FF are accepted, so beyond the standard sort of ASCII up to 7F. Then what it does is it converts those to UTF-8, which means any byte value greater than 7F gets encoded as 2 bytes. So we actually wind up making the string longer, because anytime we encounter a byte that's greater than 7F in hex, then that's going to get expanded to 2 bytes to be encoded as UTF-8. So the length of the item, confusingly, corresponds to the number of UTF-8 code points, not the number of bytes present after the encoding. So you actually have to go through and understand how to decode UTF-8 in order to actually understand the length of that. So to complicate things further, the actual bytes that were encoded from just regular bytes being treated as ISO 88591 to UTF-8, these were actually serialized Java objects that were first compressed with zlib before they were encoded to UTF-8. So we've got all sorts of crazy stuff going on. I had to write a whole bunch of code to actually be able to generate these properly. So the objects themselves are expected to be these serialized message objects, and they contain another object, which is a request object. So I'm not going to go into crazy details on this, but we're going to talk a little bit about the actual patch on the vulnerability. So the patch for work in process was small, so seeing the issue was really obvious, even if actually reaching the code was less than trivial. So again, on the left here, highlighted in red, we have the original code, and on the right in the blue, we have the new code. So any of you guys that have written Java of any sort and worked with interacting with the database and know how to parameterize your queries, you know exactly what's going on here. You see string concatenation here on the left, and you see no more string concatenation with those parameter designators on the right. So painfully obvious SQL injection. What exploitation actually wound up involving was I had to leverage the client libraries to create 2 serialized objects. So I created a bootstrap object, and that was required to kind of set everything up. There were some specific values I had to set in that bootstrap object, that related to a numeric identifier for the application and that type of stuff. But then the payload was a message object that contained a crafted FND message request object, which has a crafted resource with a name containing the SQL injection payload. So you see resource element get resource name here, and resource element get app short name. So these resources that I was basically able to add to my serialized object. So basically the message object gets decoded, decompressed, deserialized. If that object contains an FND message request object, it gets handled by FND message service respond. So then message fetch messages is called, and this is that's where this chunk of code is from that fetch messages method. So the SQL injection is actually a little harder because this time we don't have just an arbitrary, we can't just say, here's our whole SQL query, go run it. So this is more of a traditional SQL injection. So, and the rest of the vulnerabilities also involve sort of more traditional SQL injection. But thankfully, the legendary David Litchfield, author of Oracle Hackers Handbook, Database Hackers Handbook, co-author of Shell Coders Handbook, he has some awesome papers on Oracle eBusiness and Oracle database stuff, in security stuff in general. You can check it out at his website, davidlitchfield.com/security.htm. So in particular, for my purposes, he has this paper, Executing SQL as sys from apps in Oracle's eBusiness suite, which sounds pretty on the nose for what we're trying to do. That was super, super helpful. So the appendix listed a number of EBS database functions that allow for the execution of arbitrary SQL, including PL SQL, which, again, that's exactly what we're looking to do. So I wound up using this function apps ASG custom PVT, I imagine stands for private, exec command. And then as per his suggestion, David Litchfield's suggestion as well, I used the autonomous transaction pragma, and this basically allows the PL SQL function to commit data to the database without needing the outer function. So the function, the statement that we're injecting, that doesn't have to actually call commit to commit our data. We can do that right from within our injected code. So the payload wound up being something like this. And remember, this is like in serialized, compressed, encoded objects. And so this was basically what the resource name wound up getting set to. So again, I'll just walk through the payload here. So first, I finished the injectable string with some normal data. So I like to make things simple for myself to avoid as many errors in my injections as possible. So a lot of times I'll kind of like finish off part of the query as if the data was kind of normal. So yeah, and then I basically threw in a throwaway condition so that I can do a nested select at that point. So next, in that nested select, I invoke that that function that I mentioned, the exec command function, with my anonymous PL SQL block. You can notice at the beginning there's that declare pragma autonomous transaction, and that's so that I can commit the password change. So right here you see I do commit end. And again, same thing, I'm calling that FND user package change password for sysadmin, and I'm changing the password to fubarbaz789, and as soon as I send that, boom, I can now log in as sysadmin with that password. Okay, so fast forward to 2020, which for obvious reasons there's potentially ominous music because 2020 has been terrible across the board, especially this week if you run anything SolarWinds. So I noticed two more similarly scored vulnerabilities that showed up in the January 2020 patches. So these guys here, product was Oracle Human Resources for both of them, and component was hierarchy diagrammers for both of them. Cool. Remote exploit without auth, no. That's because that auth bypass was considered patched at that point. So these are also SQL injections. They involve TCF strings and no compressed or serialized object nonsense like that work in process one. So a single string sub item. So this is an example of a message for this HR hierarchy diagrammers here. So it's a single string sub item in a synchronous request, so the S at the beginning, contained a query name and parameters, and they're all separated by null bytes. So you had query name was assignment drill down here, you have the null byte, and you have the first parameters 1733, null byte, et cetera, et cetera, et cetera. So the vulnerabilities involved the second parameter, which is above here is the 1733. That was being concatenated into the query string in typical SQL injection fashion. So something jumped out at me when I was looking at the patch. And this is where things get a bit horrifying, to be completely honest. So this is the highlighted line from the patch. And so this is, this is what they changed. So here's, again, your parameter binding, pretty standard. That used to be a string just getting concatenated into there. Great. And it was that 1733 value that got put into there. But given that it's 2020, what do you think I saw on literally, I'm not even kidding, literally the next line of code? Yeah, that like string concatenation. So that's the one that was fixed right there. And right there, right underneath it is another blatantly obvious SQL injection. I could not believe my eyes. I said, no, there must be some reason why I can't inject that. And they must have covered this. They must have looked at that. No, they didn't. So yeah, there were multiple places. Like when I say free 0 days, I mean plural. So there were multiple places. So there were 2 affected class files, this exact same thing where literally it was fix the one line and then the line below and 2 lines below, we don't bother to fix. There were 3 separate locations in 2 class files. And each location, some of those parameters, like the one I just showed you, those were used in sometimes more than one location. So what we do when we happen upon 0 days like that, we report them via 0 day initiative because, well, they're part of Trend Micro, they're our coworkers, and I love the fact that they deal with disclosures for us, and I don't have to deal with it at all. I just send them a report with all my details and my POC and say, here, handle this, go talk to Oracle, and let me know if you have any questions. So those vulnerabilities were assigned CVE 2020-2882 and CVE 2020-2956. They were fixed in the April 2020 patches. And yeah, in terms of what I think happened, to me, this is probably a matter of, an internal ticket saying like, fix this SQL injection, which was followed by exactly, okay, I fixed that SQL injection, and that's all I was asked to do. So, maybe things happen that way due to, having a really heavy workload. Maybe it's a company culture thing. Maybe it's, performance tracking metrics based on, okay, how quickly can you resolve tickets and how many tickets are you resolving in a given time period? Or maybe something entirely different. Who knows? But it was a really, really horrifyingly bad thing to see, especially considering the importance of the data and the functionality for something like Oracle eBusiness for very large organizations that are dealing with potentially billions of dollars. So why do I tell you guys about all this? Why do I go into all this detail about this whole lengthy process? Well, my point is that once I had the base knowledge of the thin client framework, researching and exploiting subsequent vulnerabilities became, for the most part, simple, with the exception of maybe the work in process one. That initial research effort to get me to the point of understanding thin client framework was exceptionally time consuming. It took me, on the order of at least a couple weeks of solid work just to kind of get a basic understanding of this protocol that there's no information on. But clearly, I'm not the only person with the ability to do such things. There are tons and tons and tons of people in this industry way smarter, way better at this kind of stuff than I am. And, this is not a super crazy skill of what I did. It was basically just patience and grep, to be honest. Not everyone can patch quickly, so we hopefully have compensating controls in place when you can't patch. But how well can your compensating controls work when nobody but the software vendor understands what's traveling over your network? How many other unknown protocols or file formats are lurking in your environments? Can you protect something when you're not even aware it exists? How can you possibly, look at and see traffic for a protocol and you're like, I have no idea what this is. It's going over HTTP, but this is like weird traffic. So, where could we possibly go from here at this point? Well, large software vendors obviously are trying to protect their IP at all costs. But we need to push them for more transparency when it comes to data generated and consumed by their products. How's data structured? How does the data traverse the network? And obviously, there's a lot more details that need to go into that, but that's kind of the basics of it. In a perfect world with this whole Oracle situation, we would have a full spec document on thin client framework. We'd have API documentation for every proxy endpoint that they have, But really, it's never going to happen. I can dream, but it's just not going to happen, unfortunately. But transparency ensures attackers and defenders are on a more even playing field. When we disclose publicly this kind of information, obviously, we can get into the whole vulnerability disclosure debate, which I'm not going to get into in any way, shape, or form. But the fact of the matter is that, yes, you're disclosing this information potentially to attackers, but they could have had that information already. So it's best that everyone has that knowledge so that we know how best to deal with those kind of, what were previously unknowns. Those protocols and formats are going to exist whether you're aware of them or not. Security vendors, they can produce more detection signatures for related vulnerabilities, and they can take significantly less time to do it, which means they can get those signatures pushed out to your appliances a whole heck of a lot faster. And so, with obviously this whole SolarWinds thing in the news, we can, sort of say that, hey, you know what, like if SolarWinds was a whole lot more transparent about here's the type of network traffic, or maybe about their update procedures, for example, and making it very clear when they're pushing updates out, and, who knows what could have happened. We can only speculate at this point. So here's a few references for things that I talked about. You have the original Anapsys advisory. You've also got Martin and Gaston's talk from Hack in the Box Lockdown. So you can check that out. Just kind of see from the horse's mouth of the guys who originally discovered these vulnerabilities. The integrity article, there's not much to it. Just that's where I found the URL for the TCF endpoint originally. And then, as I said, David Litchfield's awesome paper. And he's got a whole bunch of awesome, really good stuff on that site if you are dealing with, pen testing Oracle stuff, or, doing research on Oracle stuff, or obviously defending it. Very, very helpful stuff in there. And that's everything from me for this evening. If you have any questions, please feel free to type them in the chat. You can also reach out to me on Twitter anytime at Thraki, and be more than happy to chat and answer questions that you might have.
Yeah, sure. I have one question for you, John. Where do you learn how to do this? Like how do you practice this skill?
So with stuff like this, I would often say start looking at open source applications. Sorry, I got a little bit of echo there. So I would often start with looking at open source applications, stuff that's well documented, but really so much of enterprise runs on like Java-based web applications. So, you can go and you can find trials or, stuff that will run without a license, but it'll just, cap the, the transfer rate or how much data you can put into it, and just go and start pulling these apart. Go read write-ups and try and walk yourself through write-ups for, the sort of thing that you want to research, and try and walk through and find, oh, there's the piece of code they're talking about. So if you were to go back and look at my slide deck, now, you can go grab those Oracle e-business VMs. I don't know if all of them are available, all the latest versions are, but you can at least go and find maybe some older versions of the VMs. And you can start literally following through and saying, oh, I see exactly what he's talking about. You can practice, hey, I'm going to run through the decompiler, grepping. Like I said, literally, some of the most simple tools are what gets me through. I say, okay, it's just a matter of finding that one thread and then starting to pull and pull and pull and pull. And in all honesty, as I said, grep is the tool that I probably use the most and that I make the most progress with, other than critical stuff like the decompilers. But yeah, it's just a matter of, you find little bits of information, find a thread, start grepping for stuff, and it's a lot of time and just pouring through code, but it is a lot more simple than it sounds.
That's really helpful. Thanks. My second question is how do you keep track of all this information? Like it's like, you know, thousands and thousands of ideas and like rabbit holes. Like how do you
Yep.
like organize it all?
Uh, I would be lying if I said I organized it really, really well. But one thing I have started to do, so whenever I start working on something that gets really complicated, is I will I will start like really basically just doing like a brain dump of notes. And that's one thing that I always recommend anyone who's doing any sort of vulnerability research, whether it's like 0-day research or, you know, end day like we do. I always say, as you're thinking through a problem, write down all your theories, what you're looking at, what led you to that theory. You know, you may never even go back and read those notes, but the fact that you're writing them down and you're forcing yourself to, you know, lay out your thought process and what led you to a particular theory or conclusion gives you the ability to then validate that further, as well as, you know, improving in the future to be able to say, okay, here's what I went wrong last time with this sort of thing. You know, I'll try to kind of not do that thing that cost me a whole lot of time. At the end of the day, it just becomes about, you know, how much time you spend, and over time, you're getting more efficient with your use of time to be able to cover, you know, more complex stuff in a reasonable amount of time. But yeah, absolutely. Like I literally just have a like notepad open, and I just brain dump as I hit something where I'm like, oh, this seems significant. I just start writing. I say, okay, this class file, I think it does this. Here's how it got here. You know, if I have it open in a debugger, for example, I will just literally dump a stack trace, paste that into the text file so I know how I got there. I'll make sure I write down the request I sent to get to that point, or requests if it took multiple requests to kind of get to that point. So it's really just all about making sure you're documenting stuff as much as possible. And I'll be the first to tell you that oftentimes there's things I forget to document. And when a similar vulnerability in the same product shows up a year later, I'm usually kicking myself at that point for not documenting better.
Okay, yeah, thanks a lot. Are you I mean, you mentioned Notepad, but are you like a physical Notepad guy as well, or?
That actually depends on the complexity.
Really?
So the more complex something is, so when I'm dealing with something really intense, like a really intense binary reversing, where I'm analyzing a binary vulnerability, and it involves a whole lot of intense, like just code, different function calls everywhere, and lots of confusing stuff, I tend to write it physically in a notebook. That's something I kind of took from school, where your brain treats things you write down physically differently from things you type. And so you sort of connect with that information a little better, I find, and it kind of sticks in your brain a little more. And again, I don't always go back and read these notes, but just the process of forcing you to put your thought process down on paper, it's that sort of like rubber duck debugging effect, where just saying it out loud or writing it down in some way is enough to kind of spur more ideas and to help you keep going forward.
Okay, yeah, thanks for that. Looks like we have a couple of questions in the chat here. One from Ophi. Would you recommend starting with reverse engineering patches first?
Yeah, absolutely. And the nice thing with that is because it's basically like a big sign saying, hey, look at this. Look at this thing right here. Look at this thing we changed in the code. And that's what I love about, anything open source is quite frequently, if there's, occasional open source projects out there where they will just give you this really excellent, tremendous blow by blow of what the vulnerability was. Here's the POC that was sent to us. Here's what we fixed in the code. And you can literally look at that. That's the best starting point. Then from there, you can kind of get into open source ones where it's like, okay, the commit message says we fixed this vulnerability, but they didn't really get into any dirty details on it. And that's where you can kind of start pulling those apart. So, you basically start from, here's the fixed function. You maybe have a theory. You may come up with a theory of what's going on at that point based on the description from the vendor. You may not have that kind of information. So, generally at that point, that's where I just start playing with it and saying, okay, how does this behave? throw it in debugger, start throwing data at the application, however you throw data at it. And, you basically start saying, okay, am I getting to that vulnerable point of the code? No. Okay, what do I need to change to get there? And it becomes just that iterative process. But definitely starting with patches, especially in open source. So like when we have new hires come on, onto our team, we usually have them start with stuff that has a public POC first, just to kind of get them used to our process, but also used to thinking of how to analyze these vulnerabilities and how to describe how they work. Because that's a big part of our work is, while our goal is for that network detection guidance, we provide a full root cause analysis of the vulnerability as essentially our proof. This is our proof of work that our detection guidance is as accurate and as complete as possible.
Okay. I think Ofi had a follow-up question here.
So follow-up question there. So for staying on track, that starts to become a bit of an instinct thing. So one thing that's easy to get into is diving too deep into a call stack, so to speak. So if you're like, okay, here's a vulnerable function, I see that some things were patched here, and let's say there's some function calls in that function. And when you start to dive in really deep, and let's say you've gotten like 10, 15 function calls deep, sometimes you just kind of want to take a step back and say, okay, wait, I should probably just skip over this for right now and see if, okay, do I actually care what happens in there? Do I think anything of significance is happening in there? And yeah, so it starts to become a bit of experience. And sometimes, like we frequently on our team get into situations where we just have to, say, you know what, this is too complicated for it to be feasible for us to research in a reasonable amount of time. So we have to drop research candidates on a pretty regular basis. That's just sort of par for the course for us. But yeah, in terms of the warning signs, it's when you get to a point where you're like, I literally have no idea what any of this data is for, what any of these parameters are for. It doesn't seem to have any direct relevance to what I was looking at earlier. That's where you say like, okay, let's just take a step back. That may be relevant, but right now it doesn't seem that way. And more often than not, that will help you from kind of spinning your wheels and wasting a whole lot of time. So the other question here was, how much time did I spend on these vulnerabilities? So the first, basically up to actually triggering the first vulnerability with the authentication bypass and understanding TCF and everything, I would say that was probably about a solid 3 weeks of work, which is quite a long period of time for us. We typically try to spend about a week per vulnerability at most. So what I tend to do is I'll be working on maybe some easier, more simple stuff while I've got some more difficult stuff going over several weeks. In this particular case, these I spent, I would say at least 3 weeks to trigger that first SQL injection. It took me another 2 to 3 weeks to sort out that next one with all the crazy serialization, compression, etc. And then every subsequent one after that, so those 2 SQL injections that came out in January, those took me almost no time at all because I knew exactly what I was doing at that point, and I was very familiar with the protocol. And that's my point is, I spent that initial time learning this, undocumented protocol, but as soon as any new vulnerability comes up, I know how to exploit it within a matter of, it was usually an hour or less, but by the time I was able to throw together a working exploit for those next ones. And then finding that 0 day again, like I was just analyzing the patch. I said, okay, there's the SQL injection. And I was like, wait a minute, these other ones are still there. You've got to be kidding me. I mentioned before, I didn't believe it. But again, so that was, within 2 hours, I had an existing SQL injection exploited and 2 0 days exploited. So yeah, it can be exceptionally time consuming for that initial investment. And that goes with anything new that you've never encountered as a researcher. And when you're working on a team, it's really important to be able to then go and document this kind of stuff for your team so that, that learning is not just for you, it's for everybody. And if, you're not around, let's say you're on vacation when a vulnerability drops in that particular product, using that protocol, then someone else can pick it up and get something out quickly. Any other questions?
None for me. Thank you very much, John, for coming out.
Yep. Thank you guys for having me. Really appreciate it. I enjoyed it. And yeah, as I said, anyone has any questions, please reach out to me on Twitter. You can DM me or just talk to me publicly.
Awesome. Thanks very much, John. And thanks very much for everybody who attended. Again, if you could fill out the feedback form in the video description, that'd be much appreciated. And we're looking forward to seeing you in January. Bye.
Thanks again, everyone.